welcome to my YouTube channel. To all my returning subscribers, thanks for your support. To everybody else visiting this channel for the first time, please hit the subscribe button, like the video, strike the bell notification so you get alerted when I post new content. Now, this week I'm going to be discussing cybersecurity concepts. I'm going to drop the description down below, so drop your comments also, and I'm going to do my best to respond to whatever questions you might have. So we are going to start an overview into a discussion on cybersecurity. We are going to be looking at an introduction to the essential concepts. So let us get started. We're going to be discussing what cybersecurity is, what are the technical controls. We'll talk about the CIA Triad. We'll talk about defense in depth and zero trust. And finally, we'll be finishing it up with a well-architected framework. So what is cybersecurity? Cybersecurity is the practice of protecting information assets, computer systems, networks, devices, and data from unauthorized use, access, disclosure, modification, or destruction. So to be able to assure the security of the information assets, there are different types of controls that are often put in place. These controls fall into three broad categories. They are namely the managerial controls, the operational controls, and the technical controls. So what are these things? Managerial controls are the oversight mechanisms for the systems, and they involve activities such as risk assessment, planning, auditing, testing, and evaluation. Now, these controls will aim to ensure that the security objectives and the requirements are fulfilled and that the security controls are consistent with the organizational goals and strategies. Now, that takes us to the next kind of control, which are the operational controls. Now, the operational controls are the human aspects of security, and they involve policies, procedures, training, awareness, backup, recovery, and incident response. Now, the purpose of operational controls is to ensure that the technical controls are used properly and are used effectively by the authorized user. So that takes us to the all-important technical controls, which we'll be spending some time to talk about. Now, these technical controls are basically the methods that use technology to protect information assets. They will be protecting things like software, and they will include things like security appliances, and of course other kinds of software that they will be protecting from cyber threats. Now, Microsoft Technologies will be providing various solutions that can help organizations with the prevention, the detection, and the response to cyber attacks. So, talking further about these technical controls, we said that Microsoft has got a variety of solutions, and these solutions can help businesses to implement technical cybersecurity controls, which will comprehensively protect their entire information assets like identities, like devices, like emails, like files, cloud services, apps, and data. So we're going to be having things like security analytics, threat intelligence, and automated investigations and mediations as part of the essential tools that we're going to be using to quickly and effectively deal with suspicious activities and incidents. Now, these tools will help organizations to prevent cyber attacks, data breaches, and compliance violations. And they are going to be helping these organizations as well to be able to assess their security posture and to improve their security operations. So all of these capabilities and all of these technologies will be focused around four main pillars. Now, these pillars are the identity pillar, the devices, the apps, and the data. So these are the basic things that will be protected with the help of the technical controls within an organizational IT setting. So we are going to look further at other important concepts in cybersecurity, which takes us to the CIA triad. And of course, no, the CIA here does not refer to the US organization that's got the same acronym. CIA here, of course, is talking about the fundamental concepts in information security, representing C for confidentiality, I for integrity, and A for availability. Now, these are the three main objectives of information security, and they are both interrelated and interdependent. So let's take a look at each of them, starting with confidentiality. Now, confidentiality is the principle of limiting access to the information, and we are going to be limiting this access to those that have got valid reasons to use it. For example, customers or employees' personal data should be protected and only disclosed to parties that are authorized to see these kinds of information. And again, in this space, Microsoft has got a lot of technologies that will be allowing organizations to enforce confidentiality of their informational assets. These assets could be data, documents, emails, and communications. And a few of these technologies will include things like Windows Information Protection, Azure Information Protection, Azure Confidential Computing, and Microsoft 365 Encryption. So that's that for confidentiality, at least for now. Moving on to the next one, which is integrity. Now, integrity is the assurance that information is accurate, it's consistent, and also reliable all through the life cycle of that information. Now, what this means is that any changes to the data should be authorized and verified. For example, if we have within a financial services institution, transactions should be correct and they should be traceable, and whatever modifications made should be noted and recorded and should be auditable. Now, again, Microsoft provides different kinds of technologies that's going to be allowing organizations to maintain the integrity of their data assets. And some of these technologies are Azure Information Protection, Microsoft Defender for Endpoint, and of course the Microsoft 365 compliance set of technologies, which we will also be moving on to and talking about in subsequent videos. So the third option, the third thing we're going to be discussing here is availability. Now, availability means that information is accessible to those that are authorized to view or modify it wherever and whenever they need it. For example, online services should be reliable, they should also be resilient, and they should have a backup and recovery mechanism in case of failures and disasters. Now, we will be achieving availability by using things like redundancy, load balancing, fault tolerance, and other kinds of techniques. Microsoft again offers a wide range of technologies that's going to be helping organizations to ensure the availability of their information assets, such as Azure Backup, Azure Site Recovery, Azure Availability Zones, Microsoft Load Balancer, Azure Service Fabric, and of course, Azure Traffic Manager. So we've talked about the CIA triad. We are going to be moving on to a fourth related and equally important concept, and that concept is the concept of non-repudiation. Now, non-repudiation is a principle that ensures that parties involved in a communication or a transaction cannot deny their involvement or the validity of the message or contract. Now, it is important, especially within legal, financial, and e-commerce applications, because it can prevent fraud, it can prevent identity theft, and of course, it can prevent disputes as well. So, non-repudiation will be achieved through the use of cryptographic techniques such as digital signatures, encryption, and timestamps. And this will be providing a proof of origin, integrity, and the delivery of data. Again, Microsoft gives various technologies supporting non-repudiation. And some of these technologies include things like Microsoft Authenticode, Microsoft Message Queuing, and just to mention just those two for now. We'll be talking in detail about them in future videos. Now, these technologies enable the confirmation of the origin and the integrity of digital data, data like messages, documents, and software. And non-repudiation is important for applications that need trust and accountability, such as e-commerce, applications, for example. Now, moving on further, we'll be talking about a concept that is also very important, which is the concept of the defense in depth. Now, for us to protect information and assets from unauthorized access, disclosure, modification, or destruction, we've got a strategy called the defense in-depth strategy. Now, this strategy involves applying multiple layers of protection, complementing each other and providing a higher level of assurance and resilience. Because more often than not, whenever someone attacks your environment, this is the area, that is the data, is what they are particularly interested in. So the defense in-depth recognizes that no security measure is perfect or foolproof, and that multiple defenses can reduce the risk of successful attacks. So it can be implemented starting from the physical layer here down all the way. It will be using both physical controls, both administrative controls, and operational aspects of security, and even the human aspect of security as well, to try to further strengthen your security posture. And if we want to protect ourselves against cyber attacks, Defense in-depth now employs multiple layers of security measures that increase both the difficulty and the cost of attacking your environment. And it also helps to reduce the impact of breach because it contains the scope and the severity of the damage. For example, if somebody breaches your security, your physical security, then the identity and access, of course, is going to be there protecting the down layers of your IT environment. Of course, if the person is able to breach identity and access, then the perimeter will be there to protect it, and so on and so forth. So moving on, we'll be talking about another very key concept in security, which is the zero trust. Now, zero trust is a comprehensive security approach covering the 6 essential domains of security, domains such as identity, endpoints, data, apps, infrastructure, and network. Now, it assumes that no entity or resource is trustworthy by default and requires continuous verification and validation of the interactions. So what it aims to do here is that it minimizes the attack surface and prevents unauthorized access, data breaches, and cyber attacks because it applies granular policies and controls across the entire IT environment. So the zero trust framework is based on key principles, and these principles provide multiple layers of defense. One of the principles for zero trust is to verify explicitly. Now, in this case, of course, there will be requirements for strong authentication and authorization for every access request. It also involves verification continuously of users and devices, sometimes even at multiple layers, helping to monitor and validate who can access what at all times. Now, another thing, equally important principle is the principle of least privilege access. Now, we have two kinds of things we need to be talking about here. We have what is called the just-in-time access and the just enough access. Now, these are the two techniques that apply the principle of least privilege. Now, the principle basically means that users should have the least level of access to systems and applications, and only when they need it for specific tasks. So what this does is that it reduces the chance of unauthorized or improper access. Now, another thing we want to also talk about in the zero trust principle is to always assume breach. Now, this is based on the idea that maybe we should always assume that attackers have already infiltrated our network and they are trying to access more data and resources. So what that does is that it will encourage us to adopt a deny all strategy, and we'll be using things like real-time monitoring to evaluate every request against known behaviors and to restrict and regulate access. So assume breach is the mindset of creating the necessary separation of access to further limit the damage to a small area, and in doing so, reducing the impact to our business. So moving on to something also very, very important, which is the well-architected framework. Now, this is a comprehensive guide. And in this guide, we have steps that we can use to create, to run, and maintain applications and workloads in the cloud. And it is organized into areas that are called pillars. Now, these pillars include things like cost optimization, operational excellence, performance efficiency, reliability, and security. So these pillars cover the essential aspects of cloud development and operations, and it provides design principles, questions, metrics that helps us to assess and improve the quality of the solution. It also offers a variety of tools, resources, and documentation that support the implementation of the suggestions and the achievement of the goals. So we are going to be zooming in onto the security pillar, which is an overarching pillar within the Microsoft well-architected framework. And the security pillar includes comprehensive sets of principles and recommendations that we can use to build and maintain secure cloud solutions. And it's going to be addressing key areas like identity and access management, network security, data protection, threat protection, and of course, security governance. Now, the pillar is going to guide cloud developers and cloud architects to be able to design and implement applications and services that are both secure and also reliable and compliant. And it offers a methodology for evaluating and enhancing the security level of cloud environment. So as we begin to wrap up, we'll be moving on to the shared security model, and we'll talk about the shared responsibility model. So, cloud security requires the joint effort of both the cloud service provider and, of course, the cloud customer. Now, in this case, the cloud service provider will be Microsoft, and, of course, the cloud customer is anyone that uses Microsoft technologies. So the shared responsibility model defines specific roles and tasks that each party would have in protecting the cloud environment. It will be helping us to avoid confusion and to avoid conflicts in cloud security, and also to ensure that there are no gaps or overlaps in the security controls that we have put in place. Now, a simple way to think about the shared responsibility model is to separate security into two areas. The first will be the security of the cloud, and then the security in the cloud. Now, security of the cloud means the security actions that the cloud service provider will take to protect the physical hardware. So these will be coming into these areas. Of course, we can see things like physical security, network hardware, and managed services. So those will be falling into those categories of security of the cloud. So security in the cloud means the security actions that the cloud customer will take to protect the data, the applications, the identity, access, and encryption of the cloud resources that they use. And that is going to be falling into those areas as well. Now, having discussed this, we want to quickly point out that the type of cloud service that you choose is going to be determining how much security responsibility that you have, and how much of that responsibility is going to be falling on the shoulders of the cloud vendor or the cloud service provider. But generally, customers will have more responsibility in the cloud when they have more control over the cloud resources. Like we can see here, we've got different kinds of models. For example, the traditional on-premises model means that you control virtually everything within your stack, from the physical data center all the way to data governance and rights management here. Now, as we begin to adopt the cloud gradually, a lot of customers test the waters by going to the IaaS or IaaS, or short for infrastructure as a service. And now, as we can see here, the responsibility is shared in infrastructure as a service between the cloud vendor and the cloud user. And of course, depending on which of the models that you choose, the more control you have, the more responsibilities you have as well. For instance, like we mentioned, within IaaS, customers will secure their own operating system, their apps, their data, and their network, while the providers will secure the hardware, the virtualization, and the network infrastructure. Now, if we move on to a fully managed model, for example, such as in a software as a service setting, customers would secure much more. The cloud vendor is going to be securing much more because they are responsible for much more. Like we can see here, the cloud vendor is responsible for everything between the physical data center all the way to the application, and even part of the identity and directory infrastructure. So that is basically what we've got for you this week. We're going to be discussing more about this next week. So keep a date with us.